Claude Opus 5 launched last Thursday, and Anthropic called it state-of-the-art. The week before, though, Kimi K3 reached the top of a major front-end coding leaderboard. And 1 week before that, OpenAI introduced GPT 5.6 Sol with state-of-the-art results of its own. 3 launches, 3 different winners. This all sounds impossible if state-of-the-art means the best model. So how can all 3 be right? I'm Sam Gaddis, a partner at Runpoint, where we have to choose models for real company work every day. That means I spend more time reading benchmark footnotes than is probably healthy. So to understand what these launch claims really mean, we went through more than 100 sources and turned the result into a 28-page technical briefing, which you don't have to read. I'll link it below if you want to, but this is the 6-minute version. So the phrase, the state of the art, only makes sense when it's attached to a test. It means the best score on one particular benchmark run under one particular set of rules. And that matters if your company is buying AI, because these scores influence where you spend money. A benchmark gives the model a job, sets the rules, and it decides whether the model succeeded. You change the job and you may get a different winner. If you change the tools or the number of attempts, the score can change again. If you change the judge, even success may mean something different. Now, the first AI benchmarks looked a lot like school tests. One of the most important was the MMLU. It asked nearly 16,000 multiple choice questions across more than 50 subjects. And for a while, that score was treated almost like a measure of intelligence. Then the best models got so good that they all crowded near the top. Now imagine a scale that stops at 300 pounds. 2 people step on it and both get 300. You've learned something about both people, but you haven't learned who's heavier. So the researchers started giving the model harder jobs, like fixing a real bug or operating a computer. Some of these jobs have an objective answer. A math problem is right or wrong, and code either passes a test or maybe it fails. When a machine can check the result, the model can practice thousands of times without waiting for a person. It tries something, then it gets a score, and then it adjusts. And that's the big reason that math and coding have improved so quickly while writing still feels So this is what happens when you ask the model to write an email to an unhappy customer. You can check whether it used the right facts, but judging the quality is harder. The emails should be clear without sounding cold, and any promise it makes has to fit the situation. That's a judgment task. You can measure it, but there's no clean answer key. A person has to judge the result, and 2 capable people may disagree. Human judgment makes both benchmarking and improvement both slower and more expensive. As AI moves from these math problems into real company work, more of the value sits on this side of the line. So now let's look at Anthropic's launch table. I'll put the scores on the screen, but I won't walk through every row. The table shows where the industry has managed to build an answer key. It's a useful picture of what we know how to test, while still leaving a lot of the real work that we care about outside of the frame. The clearest example in our research came from a legal benchmark. The models passed about 90% of the individual checks, but they completed only 20% of the full legal assignments. Now, both numbers can be true. A model can get most of the pieces right and still produce a document that a lawyer can't use. And this same pattern shows up in spreadsheets or longer business tasks. This is the real benchmark problem. We've become very good at measuring the parts of work with a clear answer, but we're much worse at measuring whether the whole thing is coherent and useful. And the part we measure best is also the part models can improve on the fastest. Because the benchmark supplies both the answer key and the training signal, the best models eventually crowd together at the top. Then the frontier moves toward work that depends on judgment, where the answer key gets expensive and reasonable people disagree. I think public benchmarks still matter as a filter. They still show which models are worth considering, but the buying decision really depends on the work that you need done. So when the next model launches, ask what the test actually measured. Then ask whether that resembles the work you care about. If it does, try the model on for 1 or 2 real examples. You don't need an evaluation lab for this. Just give the output to the person who normally owns that work and ask how much they would have to fix. That'll tell you more than a leaderboard about whether the model is useful inside your company. So the short version is this: AI improves fastest where the answer can be checked. More of the remaining business value still depends on work that has to be judged. And that's why every new model can be state-of-the-art, while the work you actually care about may still feel unfinished.